Hello everyone. Today we're going to be doing the Chapter 3 mid-chapter review right here. 15 questions all about Chapter 3, which is graphing equations. We graphed things in slope-intercept form. We graphed things in point-slope form. We found slopes. That's pretty much it. Solved equation. We've got a lot of stuff in here, so we'll just go over it right now. Alright, the first thing is this equation linear? Are these four equations linear? Which ones are linear? Which ones are not linear? What you're looking for is this. You're kind of looking for the things that are not linear. So first thing is you don't want to see exponents. So like this one right here with x to the third, x to the second, not linear. What you are looking for is x and y separated like this, not multiplied next to each other. Or you could just have x or just have y. You don't have to have y and x. One thing that's critical is this. If you want to graph them, you can confirm it's linear via the graph. So if I write y equals 6x, my first one, I made a straight line. That's linear. If I write y equals x minus 6, linear makes a straight line. If I graph the third one, y equals negative x to the third, it makes not a completely straight line, so therefore that's not linear. So one thing I'd advise you is graph it if you're unsure. So these are what it was. Yes, yes, no, no. Did I click yes here? I don't know. It was no. So exponent's bad. This stuff good. There's some other things that are bad, but they should be in your notes, or we wrote them in the 3.1 notes. So please refer to the 3.1 notes written and posted on Canvas if you'd like to get some information about what's good and what's bad in terms of what's linear. Okay, next one. This was a very popularly missed problem, very popularly difficult problem. So we're going to go through it. You got to do it by hand. So what they want us to do here is they want you to turn this equation into the format you see on the left over here. It says ax plus by equals c. So you're looking to get it in that form. Well, what is that form? Technically, this is kind of standard form, although Alex is a little more generous. Standard form requires that a is positive, but in Alex, it doesn't matter if you have signs negative or not. When you generally, I don't think, should, but whatever. So what I'm saying is this. You need to get a and x together, and you need to get ax and by together. So the x term and the y term, and then anything else just goes on the other side. So you can't get anything together with some parentheses. So y minus 4 equals 5x minus 10. Okay, next thing you get to decide, do I want to move the y over to the 5x or the 5x over to the y? There's really no wrong answer there. This is where your answer could divert from what somebody else might write if you had the same problem. But it still gives you a correct answer as long as you're doing the steps right. So the steps are, I move x and y together. That's my goal. Did I get x and y together? 5x minus y is together. That's good, right? However, I don't want this minus 10 here. I need to add 10 to both sides. And what that'll do is it'll make 6 equal 5x minus y. And there you go. You've got it in the right format. You've got x and y together. And it says use integers for a, b, and c. Well, those are integers. Integers means no fractions, no decimals. Only positive and negative numbers. Whoops, forgot what I just had. 6 equals 5x minus y. Okay, 6 equals 5x minus y. You'll notice I'm writing 6 first, which is the c. You don't have to write it in that exact order. If you write it reverse, it accepts it. Ta-da. Okay, number 3. Find the x and y intercept. Okay, the way you're supposed to do this by hand is you're supposed to basically, please, first of all, the x and y intercepts are absolutely not 4 and 6, just so you know. Okay? They are what you would get if you took negative 36, and divided it by each. If you do negative 36 divided by 4, let's pretend 6y doesn't exist. Look, I'm covering it up. Don't look at that. If you do negative 36 divided by 4, you get negative 9. That's the x-intercept. If you do, forget that one, if you do negative 36 divided by 6, the thing in front of y, you get negative 6, which is the y-intercept. And then the way you graph using the intercepts is after you found the intercepts, you simply click on them. So you click on the x-intercept, you click on the y-intercept. Those are 2 points on the line, and all you need is 2 points to form a line. That's the idea. If you graph a point on the line and you graph another point on the line, you connect them and you got a line. And that's the intercepts. I'm going to say this too. If you really wanted to, you could type it into Desmos. I know, I'm gonna say Desmos a lot. Desmos is a graphing calculator. Like, it is helpful to use a graphing calculator. Not only that, it tells you the intercepts too. So could you have done it without doing the work? Yeah, but this is fine. Like, I accept this. Next, graph the line y equals 5. Well, this is supposed to be knowledge you just know. A line where just y exists and there's no x is a horizontal line going through the y-intercept of 5. Now, that's how you get 1 point. Like, a lot of people I saw got that, but they didn't understand the next point. To make a horizontal line, literally any other point is acceptable as long as the line is horizontal. So what I'm trying to do here is illustrate. I could click anywhere, here, there. And as long as it makes a horizontal line, I'm doing the right thing, okay? Keep in mind, y equals something makes a horizontal line. X equals something makes a vertical line. Will you see vertical lines? You might. Alright, I saw this one. This one was very popularly missed too. I'm not quite sure. This was extremely easy. This says solve by graphing. Now, you're welcome to solve this by hand. Like, you can subtract 3 on both sides, divide by -2 on both sides, and big shocker, the answer is 3, which you would probably only find funny if you actually watched the lesson 3.2 video. So if I actually solve it by hand or do my workout, I get 3, right? To solve by graphing, you could just type it into Desmos. I mean, that's what I accept, obviously. There, I typed it into Desmos, and you'll see crosses at 3, and it makes this vertical line. The reason why it's doing that is because in Desmos, when you type in a single variable equation, it just goes ahead and graphs it straight up and down through the solution or solutions. Sometimes things have more than one solution, but this case it's 1, so it's 3. So the answer here is the solution is 3, and then to graph it, you click on 3 and then make that vertical line. It should look just like the way you graphed it a second ago. You literally type this in, it graphs that vertical line, you graph that vertical line, you put the answer of what it went through. You're doing it right. Alright, making progress a third of the way through. Number 6. For each function, state whether it's linear. First of all, what you're looking for is a pattern. Do the x's change in a consistent pattern? Goes up by 2, goes up by 2, goes up by 2. Yes. Do the y's change in a consistent pattern? 3 goes to 7 is 4, 4, 4. If both the x and y change at the same rate, you're looking at a linear function. Now, that's not always going to happen. Like, sometimes this could go up by 3, go up by 3, go up by 6, and this could go up by 4, go up by 4, go up by 8, and that would have been okay. Hopefully you're hearing what I'm thinking. It's hard to illustrate without actually doing it. Just because it's not seemingly linear, sometimes it still could be. But the cases here, I think on these Alex ones, it's pretty straightforward. If x is changing consistently and y is changing consistently, it's good. So like on the function 2, it goes -2, 0, 2, 4. Those all went up by 2. That's good. Then it goes -3, -1. That's up by 2. Then -1 goes to -5. That's down by 4. And 5 to 9 goes down by 4. That is not linear, because it didn't do this. It didn't go down by 4 each time. It went up by 2 between the first two there, which is not good. Okay, down here it goes 1, 2, 3, 4. Cool. And this goes down 4, down 2, down 1. Ooh, not linear. Then you get 1, 2, 3, 4. I mean, not 1, 2, 3, 4. 2, 3, 4, 5. And this goes down 2, down 2, down 2. Yes. Now, I didn't get it here. You might get it on yours. If you get a y value that's the same, like 5, 5, 5, 5, 5, or something like that, that actually is fine. That just means it changed by 0, changed by 0, changed by 0, which is consistent. It's okay to change by 0. So if it happens, it happens, you know? Ah, crunching my neck feels so good. Alright, next problem. Find the slope of the line passing through the points -7, -7, and -3, 6. Now, you could set this up by hand. I'm going to be using Desmos here. Let me separate it real quick. You just literally type it in, y2 minus y1. y2 minus y1 over x2 minus x1. And you get a decimal, but Desmos will very kindly convert it to a fraction if you click 13/4. That's it. You could write this on paper. This is what you should write on paper. I'd write the one y value minus the other y value. The same related x value minus the other x value. You could write it on paper, but I mean you probably end up doing like a calculator to work it out anyway. So I'm just doing it all at once to save some time. Pause real quick. I'm gonna check my World of Warcraft. Boop. Okay. Gotta move your character periodically, you know what I mean? Alright, anyways, next. Fill in the blanks below. Find the slope of the line passing through these points. So very similar to the last problem. They want you to find the slope. So I'm going to find the slope. So y2, negative 4, minus y1, 6, over x2, 3, minus 3. Tells me undefined. The reason why it's doing that is because 3 minus 3 on the bottom makes 0. And when you divide by 0, you get undefined. So make sure you pick that. On this other one here, we're going to do 5 minus 5 on top. 9 minus negative 4 on the bottom. That gives me 0 because 5 minus 5 on top is 0. So if the 0 is on the bottom, or something that makes 0 is on the bottom, you get undefined. If something that makes 0 is on the top, you get a slope of 0. They're two different things. So it's just more finding slopes, although these slopes are special cases. So be very careful of those and be on the lookout, okay? Number 9 should be yet another slope problem. I'm going to do the same thing. y2, 6, minus y1, 2. Oopsies. I don't want to sign into Desmos. And then 9 minus negative 7. 1/4. I mean, so you're just plugging it in. y2 minus y1. Now, if you're wondering where I'm getting y2s and y1s and all that stuff, y2 is, I'm choosing the second y value, 6 minus 2. Then I did 9 minus negative 7. If you do 2 minus 6 and negative 7 minus 9, it still works. Still works. Just saying. You could write these things from this first group in the front of each part of the fraction, or second. Here, I'll even do it to illustrate it. So I could have done 2 minus 6. This is backwards of what I just did. As long as I do negative 7 minus 9, you'll notice the result is still the same. So just make sure you stay consistent. If I use 2 first, it has to be negative 7 first on the bottom because those were in the same group together. But you don't have to use a particular group first. All right, for each line, determine if it's positive, negative, 0. Please, lesson 3.3, I want to say, 3.3, when we were talking about slopes in general. Somewhere near the last page, there is literally just a thing that says, here's positive, negative, 0, and undefined. Like, it just shows you what it looks like. So what you should do is, because you can use your notes, just refer to that. So right here, a flat horizontal, that's a 0. As it goes up, as it goes to the right, that's positive. As it goes down, as it goes to the right, that's negative. As it goes straight up and down, that's undefined. So you're probably going to get one of each. Just make sure you know which one's which, okay? I think the most likely mistake someone would make is mixing 0 and undefined. So please do not mix 0 and undefined. Hey, what's going on here? Boop. Okay. I'll join a group. Okay, back to this. How much does the cost of cheese increase for each ounce Carlos buys? You notice I skipped right to the question. Sorry. I mean, the answer that I'm going to find. So it says Carlos buys cheese from a farmer's market. The graph shows the cheese cost versus the weight. So the more weight he buys, you can see the cost is going up. Makes sense to me. You buy more cheese, you pay more, right? What is the cost of cheese increase for each ounce? So if you go over 1 ounce, how much does the cost go up by? It goes up to 24. So it's 24 cents. What's the slope of the line? 24. The slope is the same thing as asking the person answering the question, what is the increase in cost per increase in weight? Those things are related. Those are the slope and the same. Now, I will say this. I don't know if I'm going to get a second problem. Let me see if I'm going to get a second problem. If not, I have to talk about that last problem and go back to it. Okay, I got to talk about that last problem and go back to it. Your problem may do this. Can I see an example here? Okay, here, this side example is a good one. Your problem may, instead of starting at 0, 0, like mine did, start up. Like this one starts at 20 and goes up to, looks like 80 as it goes over 1. Now, you don't put 80 as the slope, you put 60 as the slope because it went from 20 to 80, which is an increase of 60. Mine was more obvious than this because mine started at 0. Yours might not start at 0, so you have to be very careful to actually find out how much it changes by. Okay? Alright, now we're going to continue. Write an equation in slope-intercept form and graph the line. So that's y equals mx plus b. So y equals, and you're not actually going to put mx plus b. You're going to put the slope in place of the m. 1/3 x plus b minus 2. Don't put plus negative 2. You can't do that anyways. Okay, now for graphing this, okay, first you could go on Desmos. I mean, obviously, I would recommend it if you have trouble. But the way you are intended to graph it is you start at the y-intercept, -2. And from that y-intercept at -2, you use the slope. So in our case, the slope is 1/3, which means I rise 1 and I run 3. Please always run to the right. Like, never click a second point to the left. You should always be on the y-intercept for the first point, and then the next point you should go up or down, depending on if your slope's positive or negative, and then over to the right. Over to the right, no matter what. 13. Another one. So here it is, y equals 3x minus 6. Oh, I'm sad I didn't get a negative slope. But I did get a whole number slope, which is helpful to show you guys. So in this one, the y-intercept is -6. The slope is 3, so I'm going to go up 3. But don't just go up 3 and stop. You need to go over some amount, over 1. The reason why is 3x is technically 3 over 1x. But you don't need to write that. That's like weird and unnecessary. So be careful on that one. You're just filling in the formula. It's pretty straightforward. Here it says find the slope and y-intercept of this line. Now here's the problem. None of these numbers are the slope or the y-intercept. This is in not quite standard form, but like standard form, and it's just not giving you any of that information. So what you're gonna need to do is put it in a form that gives you that information. So that information can be found in slope-intercept form. So here's what we got. I'm going to write off to the side what we want. We want y equals mx plus b. Now the key thing is y equals mx plus b, you'll notice, has y by itself. So you need to get y by itself. So to do this, I'm going to add 3x to both sides. If you haven't mastered the concept that you can move x's and y's and everything to one side of the equation or the other, you're not going to be having a good time, and you definitely need to consider getting some help. And this is like help beyond, this chapter's, the scope of this chapter, because you're going to be moving stuff around in equations for quite a while. Alright, so after I added 3x to both sides, I divided by -4 because that would help me get y by itself. And if I divide the y by -4, I need to divide each term by -4. So 3x got over -4, and -16 got over -4. And you got -3/4 x plus 4. Okay, well, what does that mean? So I have it in slope-intercept form, so what is it? So what you need to notice is this -3/4 is the slope, because the slope is always attached with the x. I mean, you might want to make it negative, unlike me. There we go. The negative can go on top with 3, or under with the 4, or just in front like I wrote. I think any of those is acceptable. Okay, and then the plus 4 at the end signifies the y-intercept. So be very careful. Make sure you're careful with your signs. Like I was careful with my signs here. I did negative divided by negative is a positive. 3 over -4 makes -3/4. So you have to be super careful. A wrong sign is a wrong answer. So do not make that mistake, okay? Last one. Brian's putting money in his savings account. He starts with $6.50, and each week he adds $40. Okay. Write an equation about S, the money in the savings account, and let W represent the weeks he's been saving. So S equals, what does his savings equal? Now you can start by writing $6.50, but I'm going to start by writing this, that he adds $40 per week, 40W. But in addition to that $40 he adds per week. Now here's the thing, I will mention this, some people had problems earlier today they were working on like this, and it just had like 40W, like that's all it needed. Sometimes you don't need more than just a number times a variable. But in my case, I have 40W, $40 per week, plus he was starting off with $6.50. Now, this is kind of in slope-intercept form. Y equals mx plus b. It just has different letters. Find the total amount of money after 11 weeks. That's a calculator's job, I guess, so I'm just going to plug it in. Please don't use S or W here. What you should do is this. You should write 40 times 11, because it's $40 a week, times 11 weeks, plus the $6.50 he had, 1,090. Time are we at? 1917. Nice. All right, we got them all done, guys. So that's the review for you. The review, it's got lots of different stuff. I'm not really gonna apologize. Chapter 3 has a lot of different stuff. But if you can master the art of finding intercepts, finding the slope of something, putting it in slope-intercept form or standard form, that's kind of it. That's kind of it. And there was a couple wordy problems, but if you can convert that into an equation, You're looking good. So maybe 5 total concepts? How many of those have you mastered? 3? 4? I hope at least 4. 3's not good enough in my opinion, but 4 or 5 would be most excellent. Or 4.5. We'll take 4.5 too. Alright, anyhow, I hope you enjoyed that video, and hope if you watched the whole thing to the end, thank you. I hope to help. That's all I can do. I can just help, right? Alright, I hope you enjoyed that, and see